Hello everyone, welcome back to the channel. I hope you guys are doing amazing, and let's just see what is there in today's daily challenge and we will solve it together. So first of all, the first step is always to understand the problem statement really clearly. Okay, what does it want to say us? So the minimum number of people to teach on a social network consisting of m users and some friendship between users. Two users can communicate with each other if they know a common language. Okay, so there are m users and you are given also n languages, and users can communicate with each other if definitely they know a common language, and you are also given an array friendship which tells you that which two users are friends with each other. So there are n languages numbered through from 1 to n, and the languages I, okay, you are given a vector languages I, which tells you languages of I tells you the set of languages the ith user knows. Okay, and friendships of I is the pair. Okay, so this vector which you are seeing is given in the function is actually a vector of pairs. Okay, and it consists of friendship between ui and vi, which two users share a common friendship, and you can choose one language and teach it to some of the users. Okay, so all friends can communicate with each other. In return, you see the minimum numbers of you need to return the minimum number of users you need to teach. Okay, and so that all the friends can communicate with each other. So whichever pair you select, they should be able to communicating with each other. And you note that this is not some graph kind of thing. So what it is told that the friendships are not transitive, meaning that if x is a friend of y and y is a friend of z, this does not guarantee that x is a friend of z. So you cannot just construct a graph and perform some algorithm. Okay, so the thing which you can do is take pairwise, take the friendship pairwise only. So if you try to see this example, n equals to 3, so you have three languages. The first language is known by the first user, the second user, the second language is known by first and third user, the third language is known by 1 and 2 users. Okay, so you are given some things like this, and there is also a 3, which means that so languages of I means that the languages with the ith user knows. So can you tell me what is the number of users here? What is the number of users here? The users is nothing but the languages dot size, because the first users can speak. So if you try to understand this example, you are given n equals to 3, that means that there are 3 languages and you are given languages. So it means that the first user can speak the second language, the second user can speak the first and third languages. So it is something like, so if I ask you how many users are there, it will be languages dot size. Okay, because this is the first element, which is 4, right? This is the first element, this is the second element, this is the third element, and this is the fourth element. So total of there are 4 elements. Okay, and so there are 4 users. It says that the first user speak the first, second language and things like that. And uh, you are given friendships also. It means that there is a friendship between 1 and 4, there is a friendship between 1 and 2, 3 and 4, and 2 and 3. Okay, so how will you approach the problem statement? The constraint are given. I will suggest you to first look at the constraint and then only continue with the video. Okay, so how so let's before approaching, let's try to summarize what are all the things told in the question. So you are given n languages. Okay, you have n languages, and what you have is also m users. Okay, and you are given something like a vector of vector languages. Okay, you have a vector languages which tells you nothing but the ith user. So it is of size m. Okay, it starts from 0 and goes all the way till, let's say, m minus 1, and it will tell you that what is the ith user using which all languages. So the ith element is also a vector which will tell you what are all the languages which the ith user uses. Okay, so each element is a vector. Okay, so you are given a vector of vectors this, and you are also given a vector of pair friendships. Okay, so it tells you that which users are friends with which of them. Okay, so you have some elements. There can be any number of elements. Okay, there can be any number of elements in friendships, and you are given only pairs, so they contain, let's say 1 and 3, it will tell you that 1 and 3 are friends. If it's given 2 and 5, then it will tell you that 2 and 5 are friends, and it will go on like this. And there can be duplicacies like this also, 1 and 3, 1 and 4, so 1 is duplicated, so it means that 1 can speak with 3 and 1 can speak with 4. Okay, 1 is friends with 4. Now what is the need, what exactly it is told is that if you try to see this example, teaching the third language to the users 1 and 3 yielding 2 users to teach. Okay, so what does it mean? What does it mean is that 1 and 4, you see 1 and 4 are friends, but can 1 and 4 communicate with each other? 1 knows the language 2 and 4 knows the language 3, so they cannot communicate. And you see, so you need to tell me that which language you need to teach to which user. Okay, so let's say the friendships you are having something like this. One is friend with, let's say 3, let's say 1 is also friends with 4, and 2 is friends with 5, and so on. Okay, so you are given these many pairs, these number of pairs. Okay, and so you need to see that first, can you tell me which are problematic pairs? Okay, so I can, let's say, have a set which are problematic pairs, or which are, I will say that which are problematic users. How do I define them? That is, they cannot speak with each other although they are friends. Okay, so the definition of problematic user is they cannot speak with each other although they are friends. So what you will do in this case, you can go through all the u comma v pairs in friends, and you see that what all languages u uses. Okay, so definitely what all languages u uses, you can easily get by language of u, and you also go through all the languages used by v. You go through all the languages used by v, and you see that if there any common language they exist, what does that mean? It will mean that they are friends and they also can speak with each other if they have a common language. But if they are not, I will tell that they both are problematic users. That is because they cannot communicate with each other although they are friends, and we need to teach at least one of them. So let's say I am telling you what I am trying to tell you, I hope you do understand, is that let's say this u, this v is friend with you, but they don't communicate with each other, they don't know a common language. So in order to make them all communicate, which the problem statement says that you need to make them all communicate, what do you need to do? You need to, let's say, this has some set of languages S1 which they speak, this have some set of languages S2 which they speak. There should be at least one common element in S1 or S2. So some language which u speaks, you need to teach it to v, or some language which v speaks, you need to teach it to u. Okay, so the thing is that now let's say u speaks, 1 speaks the language x. Okay, 3 speaks the language y, 4 speaks the language y, and let's say 2 and 5 they speak some language, let's say they speak a common language, you don't need to bother about them. Okay, so you see, since they do not speak the common language, okay, so I will try to tell you something like, let's say y. Okay, so you have this y, and let's say they also speak z. Okay, let's say 3 and 4 both speak y and z. So you see, so the thing which you see, not y and z, uh, let's say this speak a, ya and yz. So what I am trying to tell you, that since 1 and 3 cannot speak with each other and 1 and 4 cannot speak with each other, but you see the 3 and 4 have a language y. Okay, 3 and 4 have a language y, and you see that if you teach y to 1, so you take 1 and teach it y, that will do all the job, because then all of the pairs can communicate with each other. But if you try to teach x to 3, you also need to teach x to 4. So what you need to do is that you need to teach x to 3, okay, and you also need teach x to 4, you need to take the user 4 and teach x. So in this way you are using total of 2 users, okay, if you trying to teach x. But if you are trying to teach a language, note my words very carefully, be very careful what I speak now. If you try to teach the language which is more common, okay, if you try to teach the language which is more common, then you have to teach it a less number of times. So one very clear observations which come here, the major observation in this whole problem, okay, is that if you Okay, so among problematic pairs, among problematic pairs, problematic users, if you select the language, if you select the language which is more common, which is more popular or more common, then you have to teach a minimum number of users. Then you have to teach a minimum number of users. I hope you can easily understand this, right? So among a lot of users, okay, so let's say there are a lot of users, let's say there are some m users, okay, and they, let's say x of them, which is the x is the maximum value, okay, let's say this x is the maximum value among any language, and so let's say x of them speak a common language which is 1. So what is the, if you teach 1 to all of them, if you try to teach 1 to all of the possible pairs, okay, so you will require how many number of teachings? M minus x. This is the, so this is the total users, okay, among, let's say, problematic users. I am in this set, I have only have problematic users because those are only my concerns, okay, and each problematic pair you need to select at least one user, but I hope you can understand what I am trying to say is that if this is the total number of users and this many users knows a language, then the remaining users you teach the language and then all of them can communicate with each other. I hope you can easily understand that, right? Even if you think it pairwise, it's still true. It's still true. If you see that the y was most common because x is spoken only by one. Okay, they 2 and 5 can already communicate with each other, but x is spoken only by one, but y is spoken by both 3 and 4. So instead of teaching x to both 3 and 4, you teach y only to 1, and they one will easily start communicating with 3 and 4. So I hope the approach is completely clear to you. So once this approach is clear to you, what you can do, you can pause the video, okay, and try it on your own. Try the approach which I told you on your own, okay, and or otherwise you can also continue watching the solution, okay. So it will be just the implementation of what I said. So what do you need to create is the pair of users which cannot. So first I will, what I will create is that let's say not vector, I will be having a set, y set, because I will take an unordered set. So I hope you already know why I am using unordered set and not normal set and stuffs like that, because it has an amortized of complexity, okay, so which gives a better time complexity and as compared to set. And this problematic users, I hope you can understand, these are users which can't communicate with at least one of their friends, at least one of their friends. So if there exists a pair which are friends but can't communicate with each other, then they fall into the category of problematic users. Okay, so what can I do is that so you have how many m users and n languages, okay. So what can you do at first? You can just go through all the possible friendship pairs, okay. So I hope you can understand, I am going through all the possible friendship pairs. So for each pair, let's say u, you have f of 0, and for v you have, let's say, f of 1, and you see that you have these two pairs u and v which are friends, okay. So u and v are friends. Now you go through all the languages spoken by these friends. So let's say you go through x are the languages which are spoken by this user u, and y is all the languages which are spoken by this user v. Okay, so you go through all the languages spoken by u and v, and you check if they share some common language. Let's say they x equal to y, it means that they will have some common language. Then what you can do, let's say you can have a bool, flag, let's say okay, I will mark it as false initially, and if this becomes something which is okay equals to true, then you can do I mean you can break it from the loop. And also once you have broken from the outer loop, you can just check that if okay, then you can just break it. Otherwise, even you iterate through both of the loop and do not find any common language, then what will happen is that if not okay, so if they can't communicate, not okay means if they can't communicate with each other, they belong the category of problematic users, right? So you have to insert them into the problematic user. So problematic users, yes, I am just giving you. So this dot insert will be let's say you, okay, and definitely what you can do is that you can also insert this v. So you inserted both u and v with you, okay. So you now are having the pair of all these problematic users, okay. Now what you can do, you need to find the language which is most commonly spoken, okay. So how can you do it, how can you do it? So let's say I will create a map, okay. So I will create a map. So among problematic, let's say this is language number 1, language number 2, language number 3, all the way till n. One is spoken by which problematic users, okay. So how many problematic users speak one? So let's say count, it will store a count of all the problematic users, count of all problematic users which use this language, which use language 1. And similarly count of all the problematic users which use language 2, you can do it, and so on, okay. So you try to create some map like this, okay. So why I am creating this map? Because I need to find the maximum count, okay. So yeah, so let's create an unordered map. So because unordered map similar to unordered set again gives a better runtime complexity. And what will it be? It will store language count, okay. So I can tell you that what is this happening, just a second. Yeah, so I will store this map in the language count. And so what you can do now is that you can go through all the problematic users, okay. So problematic users, you are just going through all the users and just go through the languages which this particular user speaks. So let's say that all the languages is denoted by this x, okay. So x are all the languages which this particular user speak. And what I will do is very simple, is that I will have a language count of x. So this particular language x is spoken by one particular user, so I will increment the count. So I hope you know what I am doing right now, okay. So now what I can do is very simple, I will have a maximum count, okay. Maximum count of the languages, maximum known, I can call this variable maximum known, okay. So what can I do? I can iterate through the map. So I hope you know how to iterate through a map. So language comma count from language count, okay. So I am just iterating through this map and I am getting a pair of key comma value pair, okay. So the key is language and the count is high, so I need to select the language which is most popular, that is the language which is having the maximum count. So I can do something like max known is equal to max of max known comma count. So you can easily see that this is what I am doing. And what I can do is that return, I can simply return how many users do I need to teach, how many users do I need to teach, m minus x, okay. So it's not actually m, it's the size of the problematic user, okay. So how many users are there which cannot communicate right now with each other, these are the total number of users. And the most popular language, the languages which is already known by people is max known. So I need to teach the remaining people those many languages, okay. So that will give me the minimum count, okay. So I hope you can easily understand this greedy algorithm. This is a completely greedy, and I hope you do understand how is this working. With my examples I tried to tried my best to explain you how exactly selecting the language which is more popular results in teaching of the minimum number of users. Okay, so I hope this was clear to you. If you try to run it, will it work? Let's see. So it gives a runtime error. So there must be some problem. So it's the problem with is with this line. So maybe this index. So okay, what you can see is that these are one based indexing, right? So friends are you see these are just one based indexing, but as I am accessing the array elements of language, so I need to make them 0 base. So how can I convert from 1 base to 0 base? I can just subtract 1 from both u and v. So as simple as that, I guess, and it should work just fine. So let's see now if it really works. So yeah, we did get that accepted for 2 test cases. Let's try to submit it for all of them and check. So you see, we do have a pretty good runtime complexity also. Okay, so there, although this is looking like n square time complexity inside, but it is not actually. It is just n. Okay, so and if you try to just do a little bit of pen and paper, I guess you will easily get it. So yeah, that's all. That's all for this video. If you have doubt in any place, in anything, you can just ask me in the comment section. I will be happy to help. So yeah, that's all. I hope you understood with the problem, and yeah, I hope you have a great day ahead. Thank you so much.